right, so welcome everyone to today's talk, Does Your GPU Work with Free Graphics Drivers? Our speaker for this session is going to be Alyssa Rosenzweig. So just a brief description. So Alyssa is a free software graphics hacker leading Panfrost, the free software graphics driver for ARM, Mali, Midgard, and Bifrost GPUs. Furthering free software has been her mission for years, and she is grateful for the opportunity to do so as a Collabora employee. Outside free software, she studies mathematics at the University of Toronto and uses Vim to write about small ponies. Without further ado, I will let her take this.
Afternoon, everyone. I'm really glad to be here in Cambridge, Massachusetts, online, and talking to you about free graphics drivers. You already know who I am, so I guess we can get started. I'd like to get the ball rolling and say, for any GPU of interest, there's a free graphics driver for it. These states vary wildly, but we're past the days of proprietary drivers. In the lead, so to speak, you have, for example, Intel and AMD, who are leading their own free graphics drivers, as they should be, and which are well integrated into a gnu+linux desktop, which work wonderfully. Similarly, Video Core, which you'll find in a Raspberry Pi, nowadays has a free graphics driver, as it should. A little further behind, you have Mali, which is whose effort was very recently a reverse engineering effort, but which is starting to see some better support. Adreno, which is technically seeing very good results with free graphics drivers, but without the support of the vendor. Likewise for Vivante. And then in last place, we have NVIDIA, who there is a reverse engineered graphics driver, but NVIDIA has done some interesting tricks with the proprietary firmware to prevent it from reaching its full potential, earning them the place of last on this status table. Or I guess if we really must make this complete, I haven't seen one of those in years. What can I say? As you can see, this is looking a lot more promising than you might have expected, and much more promising than it looked years ago. Just in the past 5 to 10 years, we've seen a number of these efforts be born out of nothing. The picture is looking a lot nicer. Unfortunately, if you zoom in, some of the details are not quite as lovely as they appear. But even so, the fact remains, the past we've moved a long way from the dark ages of proprietary graphics drivers, where on the ARM side, at least, you need downstream kernels, or on the x86 side, you might need to have out-of-tree kernel modules built into your kernel, so-called tainting it, which is not a good thing to do to your kernel. You have proprietary user spaces, which bring not only ideological problems, but a number of practical obstacles to development on gnu+linux. And clearly you have no documentation, which means outside of reverse engineering efforts, there's little recourse to do anything about these downstream proprietary settings. And for one of my personal interests, which is environmental sustainability, there is a very negative effect of these proprietary drivers becoming discontinued after a very small period of time. And because it's proprietary, nobody else in the community can continue maintaining past 5 or so years, is often when something becomes ancient history to the industry. And given the quantity of electronic waste we see, it's very unfortunate that the perfectly good devices can't run with proper security updates on the latest kernels, which are with the latest patches and so forth, just because the drivers were proprietary. But the good news is that this is a distant memory. We don't work this way anymore. You see relics of this in some parts of the embedded space. There are unfortunately people in the industry that wish we were still living in this time or believe we still are, but I don't think so. I'm here to give you a much more optimistic message, because the present is upstream first. That goes for the user space, that goes for the kernel space. The expectation is that a device runs a mainline kernel as soon as possible. Even if it's not immediately possible to do so, the expectation is that mainlining efforts will occur. The expectation is having free software, at least in kernel and user space. This means the upstream free software project Mesa has support not only for the software rasterizers that people might expect, but also a wide range of hardware, including all of the hardware that had checkboxes at the beginning of the status table. Along with free software means some form of documentation. In some cases, like Intel and AMD, you will find the architecture specifications being released for free on in both gratis and LibreSenses on the vendor website. In other cases, you don't have the human readable documentation, but you do have machine readable specifications, generally large XML files, which might not be as good, but in practice means there are no secrets left and still carries a number of practical advantages over proprietary drivers and still eliminates the reverse engineering effort. The net result of these changes is not merely an ideological win, although it clearly is. And if I didn't believe that in and of itself was important, I wouldn't be speaking at LibrePlanet today. But there are a number of tangible benefits to this. For one, you get long-term maintenance, including a very neat resolution of the end-of-life problem. It's okay if a vendor doesn't want to support their hardware from 5 years ago if their driver is free software and upstreamed into the kernel and upstreamed into Mesa, which means anyone can continue to maintain that driver, or at the very least can continue to compile it and distribute it for the latest systems, operating systems. And in a bit more industrial setting, which I realize might not be the fancy of everyone here, but it's worth understanding if you want to understand some of the dynamics that led to this very good for free software setting. There are certain industries that require long-term maintenance of their systems. These are not generally the electronics you will think of when you think of a graphics driver. I'm not talking about your phone or your laptop. I am talking about some of the settings you might not even realize that there's a GPU running the show. All the little screens around you that you don't think twice about. As it turns out, many of them have to be running free graphics drivers and free software in general, because some of these devices need to be maintained for the next 10 or 20 years, long after the vendor would want it maintained. Having this free software benefits everyone for the long term. In much more closer to home, this is going to enable projects like Post-Market OS to continue supporting free software on aging devices and attacking the electronic waste much more directly on the consumer front. In either case, another very tangible benefit we see, and one that is in some sense a little unexpected, is considerable cross-vendor collaboration. In the proprietary world, there is heavy competition along software lines, which has always baffled me for drivers, because why would you compete against the software when you can just make better hardware? When you buy a GPU, either a discrete one or just built into your system, you you're paying for the specs of the graphics card itself. Ideally, no matter what GPU you have, no matter how low or high end, it would have the best possible drivers it can. And free software makes that possible because all of the common tasks, for instance, the baseline work required to maintain an OpenGL driver or to the front end of a GLSL compiler, this can all be shared code that everybody can contribute to and everybody can work on, even competitors within the hardware space. And so we see that this means everyone benefits. When a project that's started by Intel and contributed to by AMD can then be leveraged by a hobbyist effort for an ARM processor, that's a very incredible win. Sure, on the financial level, if you care about the business, but just from a sheer pushing free software, this is in some sense a secret weapon that we have the ability to write software that can go head to head with proprietary drivers with a fraction of the resources because we work smarter, not harder. And the bottom line is that we, as a free software graphics community, are not disrupting the status quo. You may think we are, but we're not. Because we are the status quo, and we have been for a few years now. And I'm quite happy to see how much progress we've made, and am very excited to see how much progress we'll continue to make in this space. For the next portion of the talk, I'd like to give a few case studies of some drivers that I've had the pleasure to see grow up, or which have conversely from maintainers who have helped my own driver go from a baby project in high school to something credible for production. And so these will be 3 different drivers for 3 different ARM systems and with 3 very different stories. The first is Video Core, which is a Broadcom GPU and which for the free software community is going to be notable for being in all of the Raspberry Pis in different versions. The Raspberry Pi is worth some discussion just to preface this story. It is very architecturally unusual. I don't just mean graphics, I mean every part of it. It's typically you have a CPU, whether that be an Intel chip or an ARM chip, and you have a number of peripherals wrapped around the GPU. For example, a 3D GPU for graphic acceleration, a video processor for accelerating codec support, and ultimately the CPU is the one running the show. And when we talk about writing free drivers, we mean free software that runs on the CPU with very little concern to any software running on the GPU or the VPU, although in the free software circles, we are seeing increasingly this does matter. At any rate, the Raspberry Pi, or in its system on chip, Broadcom 2835 and successors, does not work this way. Instead, you have a video processor or a 3D GPU sort of smashed together, and it's the one running the show. The ARM processor is a secondary processor, which is off to the side and which is not having the ultimate authority, at least in the main implementation. Which means even if you can run exclusively free software on this CPU, you've actually not achieved all that much for the low level because you have a multi-megabyte proprietary firmware blob running on this VPU chip. And what this meant is that when we did have an early claim of a free software driver for the Raspberry Pi, it was not meaningfully free software because it wasn't doing any of the tasks we would expect of a driver. It was simply taking the graphics calls, essentially serializing them and passing it off to this coprocessor to do all of the heavy lifting, which is not at all what we want. It does not meaningfully respect freedom, and it does not bring any of the advantages we'd ordinarily see from running a free driver. It still has similar maintenance burdens to some extent. There was a reverse engineering effort. There was some public pressure, and the bottom line is that there was change. Our first hero of the story is Eric Anhalt, a graphics ninja, who was at the time working on free software at Intel and was hired by Broadcom to work on free software for them. And Eric's results very quickly spiraled into a credible driver written from scratch for free software from day one as a part of upstream code. And interestingly, running on the CPU, on the ARM side, totally bypassing this magic firmware, which, by the way, is the same firmware that prevents the Raspberry Pi from booting with that free software under normal circumstances. And it's hard to understate the magnitude of Eric's work here with the initial video core driver, which has become a model for other Mesa drivers, and I personally maintain this is some of the best code we have in Tree. And we didn't stop there. After several years of development effort, we see that these video core drivers, now there are two of them, one for OpenGL, one for Vulkan, are supporting desktop OpenGL, and embedded OpenGL ES 3.1, Vulkan 1.0, with official Khronos conformance for both ES and Vulkan. And this to me is an incredible milestone, just to see how far it's come from a massive proprietary driver with secrets everywhere to a conformant driver being written by the vendor itself in collaboration with the Raspberry Pi Foundation and shipping in production. If this is not a success story, I don't know what is, and I'm very happy to see this. And indeed, this means there are no secrets left for the video core. The original video core used on the original Raspberry Pis has specifications freely available. Newer ones, unfortunately, do not, but there's still a XML architecture description available, permissively licensed in Mesa. If you want to know how the GPU in the Raspberry Pi works, go ahead. It's all right there. Get the code yourself. And I think that's a pretty cool thing. Changing drivers, we can look at Freedreno, which is the free software effort for the Adreno GPU. As you can see from the app name, Adreno is Qualcomm's GPU found in their Snapdragon system on chips, which are very popular among Android phones in particular. There is a good chance many of you in the audience have a Snapdragon phone, whether you hate it or not. The before times looked very similar. It's a proprietary driver from Qualcomm, and that raised some eyebrows from the Rob Clark, diviner of hardware, our second hero from the story, and who at the time was a Red Hat employee. And I suppose this is the time when I plug Red Hat because they were a LibrePlanet sponsor this year. You can check out the 2D Libre adventure with Red Hat. I'm not actually here to plug Red Hat, but Freedreno was developed when Rob Clark was a Red Hat employee, although at the time it was mostly a hobby project. And then something changed. We got some new heroes onto the story under a certain interpretation. I'll leave you to ponder the series of events that happened after Freedreno really took off. Our after time, well, I'll start with the results. Freedreno today supports OpenGL 3.2 minus a single extension, which is the gold standard for embedded hardware. It supports desktop OpenGL, and it supports Vulkan, very close to conformance. What I think is the more interesting turn of events here is that Qualcomm was not the one behind the Freedreno effort, not initially, not now. After Rob left Red Hat. Rob actually went to Google on the Chromium team. Meanwhile, also joining Google are Eric Anholt, our first hero of the story, who now works on Freedreno as a Chromium team person. And we're also seeing a number of contributors from Valve. Yes, the same Valve that is responsible for Steam, which is not necessarily known for, it's not necessarily thought of highly in the LibrePlanet type circles due to DRM issues, but in the space of graphics drivers, they have been one of the biggest proponents of free software for Vulkan, and they have made incredible contributions to the Vulkan driver along with Google. The bottom line is that we now see a major milestone that Freedreno is shipping in Chromebooks, or at least is about to be. And this is a very interesting turn of events to me, because we see this happening without the Qualcomm driver in there anywhere. Google and you, it's up to you to wonder what the reasons were, and it's not my place to say what other teams did. I was not part of this effort, but clearly they believe so strongly in free software in the graphics space that they would rather ship a reverse engineered driver on their production hardware to end users than ship this proprietary driver. I'm not telling you to go out and buy Chromebooks because it's good for your freedom. This is not that kind of talk, but it is a testament to how far the free software movement has come in the graphics space, because this would have been unthinkable even 5 years ago. For the last of 3 case studies, I want to talk about my own little baby, and that's Panfrost, although it's baby's growing up, but always be a baby to me. And Panfrost, as many of you know, is for ARM's own GPUs. It started out much the same as the past 2 cases, with a proprietary driver from ARM and no support from the vendor, with 2 new people entering to the scene. Our third hero of the day is Connor Abbott, the local wizard of Mesa, whose contributions have included the new immediate representation to Mesa, which is one of the most exciting things to happen in the free software compiler space, graphics compiler space, as well as being a contributor to Freedreno at Valve nowadays. But Connor was a wizard who reverse engineered all 4 different Mali instruction sets in a row, the 3 of which while in high school. You might be seeing a theme here, because I got involved with Panfrost when I was also a high school student. There seems to be a trend here about Mali being reverse engineered by high school students. There's 1 more Mali instruction set, which is not yet supported in Mesa. If any of you are currently in grade 9 through 12, give me a ring. I might have a project for you. But where did this go? Nowadays, Panfrost supports GLES 3.0 with very close to 3.1, and we're seeing some very interesting turns. The most exciting thing to happen in the Panfrost space this year was a quote which I will provide here, and it's on the web, so it's right in front of you. ARM are now working together with Collabora to provide us with documentation, and I'm a Collabora employee, so you do the math. This is a very big turn of events for me and for us as a team and for us as a free software community. We go from a project being reverse engineered by high school students, because who else would reverse engineer Mali, to something that's seeing an uptick of corporate interest from it, initially from Collabora, who is a longtime proponent of free software. And now all of a sudden, we are getting this recognition from the vendor, ARM making the Mali products, that maybe there's something to this whole free software thing, and it's good enough to support instead of forcing reverse engineering. And I'm very humbled to see this turn of events. And I think is a sign of better times in the ARM space to come. At any rate, even taking away some of these politics of free software, there is a number of direct benefits that we see. We support the Mali T760 and up, and we support the G71 and up within the Bifrost series, which covers a number of devices that are of interest to the free software community. One is, and the one that I originally started with was an ARM Chromebook. At the time, I was using the C201, which has a Rockchip 3288 processor. Later, I upgraded to the machine I use now, which is a Rockchip 3399 processor. Both of these have Mali hardware that requires Panfrost for acceleration. And when I got all of this started, I was frankly not interested in a lot of these philosophical musings and industry comments and all of the stories that I just told you. At the time, I just wanted my laptop to work with GNOME, and GNOME needed OpenGL, so I guess I'll write an OpenGL driver without documentation. Clearly it worked. I'm talking to you from that machine today. I'm running, this machine runs free software, including the Panfrost driver. I'm doing my background composition with OBS, which is a GL workload. Before you blame that the video quality is terrible, I will remind you that's because I'm using my integrated webcam. Please don't blame the GPU drivers for that. It's come a long way, and I'm very proud of that. A bit closer to home, or for many of you, would be the Pinebook Pro, which is very popular in the free software hobbyist space, and that has the same Rockchip processor as this laptop, so it's depending on the Panfrost driver. And this is one of the reasons why I think a number of these GPU efforts are so important, is that they are the last mile for freedom on a lot of hardware, especially ARM-based hardware. So seeing that the biggest obstacle has moved from GPUs to being much more tractable efforts, or in some cases, seeing hardware like the Rockchip 3288, which I initially started my work on, that can run with 100% free software from boot up. That's pretty cool to me, and I am pretty proud of the work we've been able to accomplish. Unfortunately, this is not without challenges, and there are a number of them, but I would like to preempt some questions and give some context on what I see as not necessarily the failures, but some of the difficulties which the much rosier picture might be leaving out. The first would be firmware, and this is something that has received a fair bit of attention, but not enough nuanced conversation. Because if I wanted to give you the graphics support table, considering the state of firmware freedom for each device, you would get a very different picture. On one hand, you have the Mali graphics, which for architectural reasons does not use any firmware whatsoever, which is a design choice which as a free software activist, I'm grateful for, but as an engineer, I'm a little baffled by, and explains some of the more quirky behaviors of the chip. It means that it can run without free firmware, or without non-free firmware rather, because there's no firmware whatsoever, there's nothing to free. It also means that you're losing a layer of programmability, so I'm not sure that's strictly a better deal in the end. On the other hand, you have chips like Intel and AMD, who nowadays require a proprietary firmware to run the GPU, but once you have this proprietary firmware, the free drivers kick in. And this is going to be a point of controversy in a space like LibrePlanet, because is that it's not clear a priori that having this firmware is necessarily a problem, but if it is a problem, it's not clear what the right way to go about fixing it is. It's easy for us to wave our hands at the sky, wave our fists rather, and say that GPUs just shouldn't run with firmware because we're not going to get free firmware for various reasons. That misses technically some of the nuances. There are compelling engineering reasons why some of these chips do use firmware. Mali, by design, does not need to. It's a very different architecture. I don't want to go as far as to call a piece of proprietary software benign, but in practice, the sorts of firmware you'll see with the free drivers are not nearly as problematic as you might expect. The big exception here is, as many of you are guessing by now, NVIDIA. Despite having a free reverse engineered driver, the Nouveau driver, NVIDIA is using a baffling technique of requiring a proprietary signed, non-redistributable firmware in order to reclock the GPU, as I said, which is practically speaking preventing the Nouveau driver from running at full performance. So despite having GL 4.5, I believe, support, it's not going to be sufficient for the workloads that people would expect out of a expensive NVIDIA discrete GPU. This is not, it's not fair to say that this is a case of firmware being evil. This is a case of a specific tactic by a specific company antagonistic to free software, using proprietary software as a means to exert power over the users, in this case, to prevent the free driver from running. It's very unfortunate that this is happening, but it's also not clear that this is generalizable to all firmware. So if this is something you are interested in, there are different approaches to how to deal with this on an individual level. There's not yet much interest dealing with it at a systemic level. I am not aware of any serious efforts reverse engineering proprietary firmware. I'm not aware of any serious public pressure to free some of the firmware that's already out there. But it's an issue to keep in mind. And as an issue, there's an NVIDIA issue that's a big elephant in the room here. If you care about ever running free software on your GPUs, I urge you to buy from any one of the vendors on the first page, aka all of them, that does not include this tactic specifically designed to prevent you from using free software. For the next challenge, I want to talk about Vulkan. And you'll notice I duplicated the slide because for this section, I just really want to be talking about some of the nuances here. So Vulkan, for those of you who don't know, is a next generation graphics API designed to succeed OpenGL in the free software space. It's competing against the proprietary APIs Direct3D12 and Apple's Metal. It's seeing considerable backing from Google on the Android platform. It's also seeing considerable backing from Valve for doing high-performance gaming on gnu+linux. The big focus is on performance, and it's a lot of work for the drivers and for the developers of applications alike. At the start, it's clear that Vulkan is an improvement over the status quo. I can tell you as a OpenGL developer, OpenGL has a very long list of problems, and Vulkan is designed to fix them. This is a good thing technically, but it's also clear that for the for free software, this means rewriting hundreds of thousands of lines of code, if not millions, once you add in application support, if you really want to get rid of OpenGL, whatever that would mean. And we have to consider the return on investment. Would we rather have Vulkan support with free software, or would we rather have, for example, GPUs that run without proprietary firmware? Ideally, we want both, and the way to get both would be to have more support for free software in general. But that seems to be the answer to all of our problems. It's rather circular and rather chicken and egg. Just having more money thrown at the problem. Where is that money going to come from? Where is that time going to come from? The list of people who are willing and able to do this sort of work is very small, and you see different priorities being set by different people in different groups. So for a current state, for Vulkan, we see the Intel driver supporting Vulkan with free software with official support, and this is an excellent shape. We see AMD supporting their own Vulkan driver, and there's also community AMD Vulkan driver, which is seeing some other backing. And we're seeing the Broadcom video core with a Vulkan driver. Newer to the show would be the Freedreno Spark Vulkan driver turnup, which is doing very well in practice, but because of considerable investment from Google and Valve, if you have the pocketbooks of Google and Valve, then sure, you can make Vulkan drivers for all the GPUs. In the meantime, I worry about prejudging drivers for not having Vulkan support, or for Vulkan support that's not moving far enough yet. For our work at Collabora, this is something we're evaluating. You should definitely look out for updates in this space. And I'm not saying, I don't want the takeaway here to be Vulkan is bad. I love Vulkan. I think it's a technical improvement, but it's important to keep in mind the cost benefits. And I just caution you to stay away from the buzzwords and try to keep to the facts. And by that, I mean, don't read the forum comments. And if I'm sure many of you in the audience know which forum I'm referring to. Similar considerations go to OpenCL, which is the API for doing heterogeneous compute, including on GPUs. It's something that we all think on paper is a good idea, having this accelerated compute support. It also raises its own set of questions. If you need just a little bit of compute support, you can get that from OpenGL and you can get that from Vulkan. If you need OpenCL, chances are you're doing very heavy-duty workloads, including, say, machine learning workloads are very popular. I'm not the right person to be commenting on how machine learning fits into the free software ecosystem. It's certainly a very nuanced discussion to be had, and I just write drivers. I can't tell you whether this is a good thing or not to have, but the fact is, it has not been prioritized, and at a personal level, I'm not sure that prioritizing this sort of work is the best use of the community's resources. Although certainly if somebody wants to start writing an OpenCL driver for Panfrost, I will merge those patches, and I already have. It's work in progress. So I think that's all for today for what I have prepared, but I believe I raised a number of questions, probably more than I answered. So I would love to start a questions and comments or questions and answers session if that's something people in the audience are interested in. Thank you.
Alyssa. So we do have a bunch of questions in the IRC chat right now.
Right.
So one of the first things that came up was, can you go back to one of the first slides at the with the checkboxes on the vendors which are FOSS friendly? and that would be great just to see which.
I think I will openly admit that this was the first slide, and I wanted this to be a flashy piece of optimism. I hope I have outlined why they have the order they have. If you're looking for a buying guide, look at some of the more details, but it's just a list of all the GPU vendors in use right now, honestly.
Another question from Bradley. Alyssa, thanks for focusing on software freedom in this problematic space. If you had to pick one or two desktop video cards that are the least proprietary GPU-wise and do have free software drivers and still relatively modern, which one of your initial lists would you pick? I'd really like to know specific models you'd suggest buying. Not asking for a friend. He has a computer that was built by volunteers.
Right, so in the desktop space, both Intel and AMD are going to be good bets. Intel, if you have a Intel chip, that's going to be an integrated graphics card, and that's ubiquitous because how could it not be? AMD is going to be much more popular for discrete graphics cards, which is not my area of specialty. If you are wanting to do high performance video games, obviously AMD is the leader in this space. I'm going to discount that last item on this slide for reasons extensively discussed already. Both Intel and AMD are going to have the proprietary firmwares nowadays. If that's something you're okay with, they're both going to have excellent driver support.
Bradley says, he's not going to play games on it anyways.
That's sort of one of the things that I found a little funny about my personal involvement with graphics drivers is that I don't play video games. The vast majority of time I've spent playing video games in the past couple of years has been testing code for drivers. I just want to run GNOME on my machines, and for that, the integrated GPU on an ARM Chromebook is more than sufficient. But what do I know?
So another question by Kiliro. These are kind of two questions in one. How do you get students involved in reverse engineering, and where do you route students who are interested in learning more?
Ironically, I'm not sure I'm the right person to ask. I joke about being a high school student when I did this. Let's say I was doing this while I was high school age and begrudgingly getting my high school classes in. I'm not sure a student would have been top of my adjectives at the time. The people who do the best reverse engineering work are the ones who are intrinsically motivated to do so, and will do so not because somebody told them to, but because everybody told them not to, and they had a fire under them and they wanted to prove everyone wrong. I joke that Panfrost started from a much more experienced free software hacker explaining to me the reason why my Chromebook didn't have free drivers was because only an expert could work in the graphics space, and I was 15 and extremely cocky. So it's like, hold my beer.
So there were a couple more questions, but I think we've sort of run out of time. So Alyssa, for the amazing talk.
Thank you.
And we'll have like a couple minutes of rest, and then we'll go again in this room for.
All right. I will be on IRC. You all know how to reach me. I'm happy to continue this there. Thank you.